I would like to ask what it is the right level of GH, EGF-1, after the year of 50, roughly, because as we know, as you showed, it helps to cure. On the other hand, it makes you grow, so it can accelerate the cancer cells. And the second question I have, when do we think with Tornado that we will have a Rapalog ready to be used and safe? Thank you very much.
Okay, you can hear me. Yeah, so thank you for that question. Right now, when we measure our growth hormone levels, the laboratory will usually give an age-adjusted number. So because every laboratory gets slightly different levels, and so there isn't one level that I would say is ideal, but there are age-adjusted levels that that laboratory identifies. And so I would say that as long as your level is where it should be for your age, or maybe even a little bit lower. I don't think that your level should be 0. I'll start with that, okay? I don't think we need to push those levels completely down, because I think there might be harms, and we saw that even in older people who had very low levels, it did slightly increase their risk. So I would say probably somewhere in the lower 25, 25 to 50 percentile range for your age.
And I can only speak for Tornado Rapalogs. If things go well, which they often don't in clinical development, but if they went well, probably around 2030, if, optimistically, they could get approved.
Thank you. Yes, please. C'è una domanda qui. Ah no, scusi, dietro.
Valerio. Okay.
Please.
A question perhaps for Alberto Beretta. In the context of aging, an important theme is that not every organ, not all organs age at the same time. So another open question is which organ starts the process, and that has of course important implications. There's been reports very recent where people, researchers from bloodstream can anticipate which organ is actually compromised. Your test can also go that far? Or can you anticipate, or can you compare your data to any clinically evident defect in a given organ? From a liver or heart or any other?
You're referring to the radar or the Grimage?
The Grimage.
Sorry, the radar.
Right.
No, the radar is essentially done on blood cells, on lymphomonocytes. So it doesn't.
From blood, instead of from blood, you can.
Sorry.
Or from blood.
Sangue.
Yes, peripheral blood. Yes.
Right.
Yeah.
So can you from blood go back to the organ?
No, we can't. No, I really don't. That would be fantastic. But
yeah. This is something that other people use in
I agree. Yeah, sure.
So yeah, I'd like to
David has a comment.
Add some flavor to that answer. Today, it's not available such a test, right? But there are developments, and you mentioned one, Alberto, the work from Tony Wiscorey at Stanford, looking at proteomics.
Right.
The work we are doing on transcriptomics, so it's not epigenetics, but based on a large cohort of individuals that have died, and you can generate different clocks for different organs, and you have paired blood samples. And so you can take machine learning AI and build clocks using blood that predict organ aging. Those things are under development. They're not ready for prime time yet.
Yeah, okay.
Okay, thank you. There was a question here, qui in seconda fila. Two questions.
Thank you. a lot of evidence of the exercise and benefiting aging and the different level of exercise. Have you seen some negative effect on aging for over-exercise? I'm thinking about, I don't know, Ironman-like exercise or stuff like that.
Okay, I can add something. If you consider exercise as a drug, it works exactly as a drug, which means that there is a dose-response effect. The more drug you take, the more effect you have. At a certain point, sometimes there is a sort of the J curve, the reverse J curve. So at higher dosage, if you increase so much the dose, you could have some problems. But at the moment, as far as I understand, as far as I know, there are no evidences in showing this effect in aging. So too much exercise affect aging. Too much exercise affect normally, but when I say too much exercise, it means excessive exercise. I mean the triathlon, okay? We are normally very, very far from excessive exercise, very, very far.
Silvano, I'd like to ask you something, if you don't mind. I can just, open the discussion here on that front. I have 3 kids, and I always try to make them move around and do some exercise. But in your research or all the work that you know of in the literature, are there different regimes for different ages? And how would they look like? Someone in the 30s, someone in the 60s, someone in the very early ages of, say, 5 or 10 years old?
Okay, so there are, let's say, some evidences. If you consider what the WHO is saying, for example, WHO is stating that every child should accumulate at least 1 hour a day of exercise and physical activity. Whilst every adult should accumulate, we say, at least 150 minutes a week. But again, I would like to stress that one, at least. So 150 minutes a week, which means 30 minutes a day, something like that, is not the dose, it's the minimum dose. Then the more you do, the better it is. You have seen, I love the slide that you have taken from our booklet. Maths hour is a measure of volume. So the more volume you do, the lower the risk of cancer. So the more you do, the better it is. Kids should do a lot. What type? Strength and resistance, which is strength and resistance exercise is a metric, is a measure, is a way of saying which is good for us. Your children, they should, let me say, they should swing, they should jump, they should throw, okay?
Prego.
In daily practice, we discovered that the list of diseases is not that important. What is important is the functionality. When you lost the functionality, you are done.
Yeah.
So, how do you, I heard something by Dr. FURMAN about function, but I would love to know by the panel, where do you put the function in your measurements or in your therapeutics? Because we know that the 4 meters walk is more predictive of mortality than anything else. Cardiac index, blah, blah, blah. So, can we combine the clinical side with your biological measurements?
Yeah, I can just give a short answer to that question. So in the INSPIRE cohort is the cohort I mentioned that was derived from the iCope app with 45,000 people. In 1,000 of those, we're following over 10 years. And the function with using actually an app, right? Easy way to measure function. In terms of self-reported function. It's really interesting what happened in France. This is has been implemented in France. The moment you see a decline in one of these 6 domains of function, and that includes mobility for sure, there's a red flag and a nurse is called in. And so can you imagine the entire infrastructure that the government has put to derive that person who has not developed a disease yet, but is declining in function to their primary care physician. And we're measuring all those aspects of function, including the, once a year they come to the clinic and do the actual assessment of function. And we're measuring as well all the biomarkers, all the omics. So this is actually work in progress. Yeah. Intrinsic capacity, the idea of maintaining intrinsic capacity.
Thank you. Do we have?
Can I just add something to that
Yeah, sure.
that I think
Please.
is really important? So function is often like right, a precedent to disease. It's something that happens before disease occurs. So for example, for diabetes, right, we might see, like, we can measure it as blood sugar, right? The blood sugar goes up, but we're not really seeing the outcomes of disease. So something like reduced mobility, right, may be a precursor, right, for what may be to come. And so when we're actually developing, I think, a lot of our therapeutics, right, we're actually looking at markers of functional decline or early markers that are not really quantified as disease yet, but they may be kind of a predictor of something to come. Because once a disease develops, it's very difficult to then reverse it, right? You might be able to maintain it, but it'll be very difficult to actually go back. But if you catch it really early and you introduce your therapeutics early enough, then you may prevent that progression.
And there are standard tools to measure that. The integrated care of people, of elderly adults, ICOPE is one of them.
Dunque, c'è una domanda lì, prego.
I want to ask you, we spoke about biological profile and then about physiological profile. And also you mentioned that prevention comes through exercise. I want to ask you, is there a possibility to develop a connection between posture that is connected to the body, to the movements, etc., and these two profiles that you are actually able to measure, to make it easier or faster to have a kind of diagnosis of something happening through the posture? Because posture apparently now can be measured by AI in 150 measurements. So maybe there is a connection, and maybe it's a faster diagnosis, possibly.
Yeah, I think there is possibility. We don't do that, but we can do that very easily because there are software and camera-assisted system to measure posture. Posture is one of the parameters we measure. We measure also, walking and everything. Usually the patient is really undergoes a thorough physiatric assessment, and that's exactly what you're asking. Is exactly what we're hoping to do, to integrate all this data together. Once we have accumulated enough data from at least 100, 200 patients, then we will see which one correlates with which one, okay? Because we really don't know yet. It's just the infancy, this project. All the biological parameters, how do they correlate to physiological parameters?
Prego.
We heard that, I'm here. We heard that mTOR is activated, stays activated later in life, and is a bad thing. And then we also heard about exercise activating mTOR, and it's a good thing. So we have a paradox here.
So when you're young, mTOR is important, and it's sort of maintaining mTOR in the right level. You need mTOR to build muscles because mTOR makes proteins and lipids that you need to build muscle. But when you get older and it gets hyperactive, you start actually breaking down muscle and getting muscle atrophy and weakness because there's too much mTOR. So it's just a matter of turning it down to the young level in the older person, not turning it off, because you're right. If you turn it off, you'll stop building muscle.
Abbiamo una domanda dietro.
Thank you. I have a question for Sofiya MILMAN. Why there's such a difference between men and women, as you mentioned in your relation, for the effect of the EGF-1? And also, the other little question is about the binding proteins of EGF-1. We know that we have like 6 different binding proteins that can have a different effect on the EGF-1. So what can we do about this? Thank you.
Yeah.
Yeah, okay. The male-female conundrum, I think, still puzzles us. I would say that in our work in centenarians, so 75% of our centenarians are actually female, right, because women do live longer. And so most of our data actually comes from females, and we have very few males. So it may be that we just didn't have enough people to see the difference. That's a possibility, because when we look at people who were younger, right, 65 and older, and we had a lot more of them to look at, about 800, and when we looked in the UK Biobank at 400,000 people, we did not see sex differences. So it may be that we just didn't have enough power to discover it. Now, that being said, in intervention studies, I showed you data from female mice, they didn't see the same effect in males. So there may still be sex differences in the way different sexes respond to lowering of growth hormone. I think we'll have to explore this further, for sure. Regarding the binding proteins, so in circulation, the growth hormone is not just circulating by itself, right? There are 6 binding proteins that attach to it because that allows it to circulate for longer. Otherwise, it just gets broken down very quickly. But the binding of the growth hormone to the binding proteins actually prevents it from binding to its receptor, so it blocks, right, its ability to do its action. So the binding proteins allow you to very tightly regulate how much of that hormone is free and can actually do the job, right? Because you can have a lot of hormone, but if it's all bound to the binding proteins, it will not transmit the signal. So what we're finding is that higher levels of IGF-BP3, which is the most abundant binding protein in circulation, seems to be protective for aging as well. IGF binding protein 1 seems to be associated with mortality, so higher levels are associated with mortality, but it might be an IGF independent effect because the job of binding proteins is not only to bind IGF, but they have IGF independent effects as well. So very interesting that we still need to explore.
Okay, thank you. We have one, two, three, and then no, 2. One question there and one here. E poi I think we need to close, right? Yeah.
Thank you. I've got a question for Sofiya MILMAN regarding the GH. When probably I missed one point. We saw that at some point we had to have a very low GH growth hormone in our late life, and I would like to know if there is any conservative way to maintain that, and what we should do in order to maintain the GH very low. Probably the answer is physical activity and deficiency in calories deficiency, but probably I just missed the point. And also I've got another question for Silvano afterwards regarding biomechanics and the quality of movement rather than quantity. If you ever consider the quality of the movement of the human beings in order to control if that could be increase or reduce the inflammation and increase the longevity.
Okay, I'll go first. So caloric restriction does tend to reduce growth hormone levels, right? I think it's very difficult to maintain, but maybe you don't have to maintain, that degree of caloric restriction, right, that was instituted in the calorie diet. Maybe just, maintaining a reasonable caloric restriction would be helpful. I also think not eating all the time is helpful, right? So really timing your meals and having periods between your meals when you're actually fasting, because that will turn down your growth hormones levels, because when you are lacking calories, right, when you're lacking energy going in, you're gonna divert your energy away from growth and towards maintenance. And so if you have periods of fasting, then you're not gonna be making growth hormone because you don't have the substrate for it, right? You don't have the energy. So you're actually gonna shift yourself to repair and autophagy processes. So that may be one way, like not to snack. I don't know, you guys might be better here in the States. People snack all the time. So that might be one way to do it in a more conservative way.
Silvano?
Yes, as far as I know, there are not studies evaluating the additional effects of the quality of movement as an addiction to the quantity. To do a study like that, we should have people being normalized by volume, and then adding also on top of that the quality of movement to see what happens in longevity, etc. I don't know if there are studies done on that at the moment.
I'm sorry, I'm not a doctor, not even a researcher, so maybe my question sounds silly to you. But I was wondering, is there any gender-based difference in the level of the growth hormone in middle-aged people, and especially if it is linked to women who gave birth during their life?
So women do have lower levels of growth hormone throughout life. I don't know the answer to your question about...
So maybe it's not so relevant. Thank you.
Sofiya, I have a last question. There are some, genetic conditions in which, like, you produce very low quantities of growth hormone, or you don't, like dwarfisms. What happens there as the whole system is screwed up?
Right, so there are several genetic variations, right, that impact the growth hormone axis. So I think a very telling example are individuals who have a mutation in the growth hormone receptor, right? So they essentially are lacking the growth hormone receptor, so the growth hormone cannot bind to it and cannot transmit its signal. So it's like they have no growth hormone at all. So they're very short, but they almost never get cancer, and they're protected from diabetes. And so this suggests to us that it might actually be protective for these age-related conditions to have low levels of this hormone.
So if you're told that's bad.
I wouldn't go that far.
Okay, good.
Because actually your height is not only controlled by your growth hormone.
Thank you to the discussants. This was like a very exciting and stimulating panel. Thank you. E grazie al pubblico perché siete stati veramente coinvolti. Grazie.